Preparing for an AI testing engineer interview. You've reached Interview Guide, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How is testing AI or ML systems different from testing traditional software? Traditional software testing checks deterministic logic. AI testing checks probabilistic behavior learned from data. I still validate APIs, UI, and integrations, but I add dataset quality, model metrics, bias, robustness, and drift tests. Expected results are often ranges or statistical thresholds, not exact values. A good strategy combines unit tests for pipelines, offline evaluation on labeled data, and production monitoring because model behavior can change after deployment as real-world data shifts. While answering, focus on probabilistic behavior, data dependency, changing production distributions, statistical thresholds, model evaluation metrics, and why testing must include pipelines, datasets, model behavior, and monitoring. Question 2. How would you define a test strategy for an ML model before production release? I start with risk. What failure hurts users or the business? Then I verify data schemas, feature transformations, train validation splits, and reproducibility. For the model, I test accuracy plus precision, recall, calibration, fairness, robustness, and performance against baseline and champion models. I also review error slices, not just averages. Release criteria should be measurable. Minimum metrics, no critical bias regression, acceptable latency, and rollback readiness if live telemetry degrades. Make sure to cover risk-based planning, data validation, feature pipeline checks, baseline comparison, offline metrics, error analysis, fairness, latency, reproducibility, rollback criteria, and measurable release gates. Question 3. How do you create representative test data for an AI system? Representative test data is engineered, not randomly collected. I map key user segments, input types, edge cases, rare events, and failure modes, then sample or synthesize data for each. I keep a locked golden set for regression and a rotating set for freshness. Labels need quality checks, inter-annotator agreement, and audit trails. I also protect privacy through masking or synthetic generation, because realistic data should not become a security risk. In your answer, talk about user segments, edge cases, rare scenarios, balanced and imbalanced classes, label quality, golden datasets, privacy controls, synthetic data, and test set freshness. Question 4. How do you choose evaluation metrics like accuracy, precision, recall, F1, ROC-AUC, or calibration? Accuracy is useful only when classes are balanced and errors have equal cost. In fraud detection, recall may matter, because missed fraud is expensive. In medical alerts, precision matters to avoid alarm fatigue. F1 balances precision and recall, while ROC-AUC shows ranking quality across thresholds. I also check calibration, because a 0.8 probability should mean roughly 80% likelihood. The metric must match the product decision, not just look good on a dashboard. Be sure to mention business context, class imbalance, cost of false positives versus false negatives, threshold selection, probability calibration, ranking quality, and why one metric rarely tells the full story. Question 5. How do you handle non-deterministic or flaky tests in AI systems? AI tests can be flaky because training uses random initialization, parallelism, sampling, or external model APIs. I reduce this by fixing seeds, pinning library and model versions, controlling prompts, and testing distributions instead of exact outputs. For LLMs, I set temperature low for regression tests and use semantic evaluators with clear thresholds. If a test remains probabilistic, I run repeated trials and track confidence intervals, so failures indicate real degradation, not noise. While answering, cover randomness from training and inference, seed control, pinned versions, statistical assertions, repeated runs, confidence intervals, low-temperature LLM tests, and separating true regressions from noise. Question 6. What is metamorphic testing, and how is it useful for AI testing? Metamorphic testing checks relationships between inputs and outputs when exact labels are hard. For example, if I slightly brighten an image, a robust classifier should keep the same label. If I translate a sentence, sentiment should remain similar. I define transformations that preserve or predictably change meaning, then assert model behavior follows. It is powerful for AI because we often cannot label every case, but we can define invariants that catch brittle models. Make sure to explain input transformations, invariant relationships, cases where labels are unavailable, examples from computer vision or NLP, and how metamorphic tests expose brittle model behavior. Question 7. How would you test an AI model for bias and fairness? Fairness testing starts by defining protected or sensitive groups and the harm we want to avoid. I compare metrics across slices: false positive rate, false negative rate, acceptance rate, and calibration. I also inspect intersectional groups, because averages can hide issues. If I find bias, I trace whether it comes from labels, sampling, features, or thresholds. The goal is not perfect equality everywhere. It is transparent, justified behavior aligned with legal and product requirements. In your answer, include protected groups, slice-based evaluation, disparate error rates, intersectionality, label bias, feature leakage, fairness thresholds, documentation, and collaboration with legal, product, and domain experts. Question 8. How would you test an LLM chatbot for hallucination, safety, and prompt injection? For an LLM chatbot, I build evaluation sets around real intents, adversarial prompts, unsafe requests, and knowledge-grounded questions. I test factuality against trusted sources, refusal quality for prohibited content, prompt injection resistance, toxicity, privacy leakage, and response format compliance. Automated judges help, but I calibrate them with human review. I also log citations, retrieval context, and confidence signals. The best setup combines offline red team tests with production monitoring for new hallucination patterns. Be sure to mention evaluation datasets, grounded factuality checks, red teaming, unsafe prompt categories, refusal behavior, toxicity, privacy leakage, prompt injection, human review, and monitoring live conversations. Question 9. What are data drift and model drift, and how do you detect them? Data drift means production inputs no longer look like training data. Model drift means prediction quality changes. I monitor feature distributions, missing values, embedding similarity, prediction distributions, and outcome metrics when labels arrive. Statistical tests like PSI, KS test, or KL divergence can flag shifts, but thresholds need business context. When drift appears, I analyze slices, compare against recent labeled data, and decide whether to retrain, adjust thresholds, or roll back. While answering, distinguish input distribution changes from performance degradation. Then cover feature monitoring, prediction distribution shifts, delayed labels, PSI, KS tests, alert thresholds, retraining, and rollback decisions. Question 10. How do you perform adversarial testing for AI models? Adversarial testing asks, how can a user or attacker make the model fail? For vision, I may add noise, blur, compression, or patch attacks. For NLP, I use typos, paraphrases, jailbreaks, and prompt injection. I measure how accuracy, safety, and confidence change under these perturbations. Defenses include data augmentation, input validation, robust training, rate limits, and guardrails. I never treat robustness as one test. It is an ongoing threat modeling practice. Make sure to cover threat modeling, perturbations, malicious inputs, jailbreaks, prompt injection, noisy images or text, measuring degradation, robustness thresholds, guardrails, and why adversarial testing is continuous. Question 11. How would you integrate AI model testing into a CI/CD pipeline? In CI, I separate fast checks from expensive model evaluations. Every commit should run schema tests, unit tests for feature code, prompt templates, data contracts, and small smoke evaluations. Nightly or pre-release jobs can train models, compare metrics to baselines, run bias tests, and validate artifacts. I version datasets, features, models, and configs, so results are reproducible. A deployment should fail automatically if quality, latency, or safety gates regress beyond agreed thresholds. In your answer, discuss fast commit checks, data contracts, feature tests, prompt tests, model artifact validation, baseline comparisons, scheduled evaluations, reproducibility, versioning, and automated quality gates. Question 12. What would you test when evaluating the performance of an AI inference service? AI performance testing is not only average latency. I measure P50, P95, and P99 latency, throughput, cold starts, GPU or CPU utilization, batch size effects, memory usage, and timeout behavior. I test realistic payload sizes and concurrency, including peak traffic. For LLM systems, token generation rate and context length matter. Then I tune caching, batching, quantization, model size, and auto-scaling. The trade-off is usually quality versus cost versus responsiveness. Be sure to mention latency percentiles, throughput, concurrency, resource utilization, batch sizes, cold starts, context length for LLMs, timeout behavior, scaling, cost, and quality performance trade-offs. Question 13. Why are feature validation and data contracts important in AI testing? Feature validation catches bad inputs before they become bad predictions. I define contracts for type, range, nullability, categorical values, freshness, and relationships between fields. For example, account age days should never be negative, and currency codes must be valid. I enforce these checks in training and serving so both paths match. When violations occur, I log, alert, and choose a safe fallback. This prevents silent model degradation caused by upstream data changes. While answering, focus on training serving consistency, schema validation, nulls, ranges, categorical values, freshness, upstream changes, logging, alerting, fallback behavior, and preventing silent model degradation. Question 14. How do you balance manual testing and automated evaluation in AI products? Manual testing is valuable for judgment-heavy areas like conversational quality, fairness nuance, and safety edge cases. Automation gives scale, repeatability, and fast regression feedback. I usually start with exploratory human review to discover failure patterns, convert those patterns into automated test sets, then keep sampling production outputs for human audits. For LLMs, automated judges must be validated because they can be biased or inconsistent. The strongest process uses both, with clear escalation rules. Make sure to compare exploratory human review with repeatable automation. Include LLM judge validation, sampling production outputs, subjective quality checks, safety review, regression suites, and escalation workflows. Question 15. A deployed AI model suddenly shows a drop in accuracy. How would you investigate? When a deployed model drops in quality, I first confirm the signal is real. Metric definition, label delay, logging changes, and sample size. Then I slice by user segment, region, device, feature values, and model version. I compare training serving skew, feature drift, dependency changes, and recent releases. If user impact is high, I roll back or route traffic to a stable model. After containment, I run root cause analysis and add regression tests. In your answer, walk through confirming metric validity, checking label delays, slicing errors, investigating drift, training serving skew, dependency changes, recent deployments, rollback decisions, and adding preventive tests. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.